Good day, everyone. This is another great section in this class. And please make sure you subscribe to this channel and turn on our notification bell. Don't skip any part of this video in order to get the full details about this section. So we have another section in integration of special types. And today we are looking at integration of types in direct phi of x and f of x dx. And they're telling us the answer is going to be the natural logarithm of f of x plus c. Now, what do you mean of that? This means if you have a quotient function or a fraction, and you discover that if you differentiate the denominator of the fraction, the answer will be the numerator. Automatically, the answer to the problem will be log of the denominator plus c. For example, let's say you have a problem, you are integrating the problem and it's a fraction. And if you differentiate the denominator of the fraction, the answer will be the numerator. So the integral of that full fraction will be log of the denominator plus c. Let's check for this. For this question, our denominator, like the denominator is x. Then the numerator, if you differentiate f prime, we differentiate this function f of x. Differentiating x, you're going to have what? 1. So if I differentiate this denominator, I'm going to have the numerator. If I differentiate x, I'm going to have 1. So now telling us if you discover that if I differentiate the denominator, you have the numerator, the final answer will be log e of the denominator plus c. That will be the final answer to the integration. I hope you get it. Look at it. If you see a question which is a division question, that is a quotient function, and you are integrating the function, check if you differentiate the denominator, the answer will be numerator. If you differentiate the denominator, the answer is numerator, the final answer of the equation will be log of the denominator plus c. Let's check this other one. Now let's differentiate. Our denominator is 3x plus 2. So if you differentiate this denominator, you're going to have the 3x, you have 3, and the ratio 2, you have 0. Ratio 2, you have 0. So right now, let's see, I'm going to do in this place now. You check. If I differentiate this denominator, the answer is 3, which is the numerator. So automatically, the final answer to the question will be equal to log e of the denominator, which is 3x plus 2 plus c. That will be the final answer to the question. Why? Because if I differentiate this denominator, the answer will be numerator. If that is the case, the integration of everything will be log of this denominator plus c. I hope you are getting it little by little. So let's try this next one. So I would like to use the long approach to solve that next one, so that you see the difference between the two methods. So let me use the long approach to solve that one. Let me start from here so that we have enough space. We have enough space to do it. So what I have is 1 plus 2x dx over 9 plus x plus s squared. Let me use the long approach to do this. This is number 3. Let's go to cut to this place because since it's a little bit long. That's number 3 question. So the first thing we are going to do here will be let the denominator, let u be equal to the denominator plus x squared. That is the first thing you do. The long approach is what I'm using now. Then the next thing, question will be integral 1 plus 2x to dx over u. Now, we cannot integrate u with respect to s. Forget about the numerator, we are talking reciprocate, or we are taking preference to the denominator now. We cannot integrate the u with respect to s. So we are going to find the equivalent value for u that is in the x. What I'm going to do, we are going to differentiate this function. du over dx. Differentiate this, you're going to have 0 for 9, 1 for x, 2x for s squared. So the next thing, we multiply, du will be equal to 1 plus 2x dx. That's what I'm going to have. 1 plus 2x dx. So next thing from this is making the s the subject of the formula. We will divide this side by 1 plus 2x. Divide the other side by 1 plus 2x. This will cancel this. so that the x will be equal to the u over 1 plus 2x. That's where I go around the u over 1 plus 2x. So anywhere you see the x in this place, you put the u over 1 plus 2x there. You put the u over 1 plus 2x, so that we'll be having integral 1 plus 2x over u. Then the x means, this dx means the u over 1 plus 2x. That's what it means. This one will cancel this. We'll be having integral du. Okay, let me just say integral 1 over u du. Remember, if we differentiate 1 over x, the answer will be what? Log of x to the base e. So if I differentiate 1 over x, okay, remember if you integrate, if you integrate 1 over x, the answer will be log of that x to the base e. If I differentiate log u with respect to u, the answer will be 1 over u. If I differentiate log x to base e with respect to x, the answer will be 1 over x. So if you integrate 1 over u with respect to u, the answer will still be log e of u plus c. That's where I go. Why? Because if I differentiate log u with respect to u to base e, the answer will be 1 over u. So we already said integration is anti-differentiation. So that's how it is. So from here, now I have log e. What is u? U is 9 plus s plus s squared. 9 plus x plus s squared plus c is what you are going to have as a final answer. As a final answer. So then if you wish to use that our normal method, you will check. If I differentiate this, will the answer be this? Let's check. Derivative 9 is 0. Derivative x is 1. Derivative x squared 2 is r. If I differentiate this, the answer will be this. Since if I differentiate this one, the answer is this. The final answer will be this. So the final answer will be log of the denominator 9 plus x plus s squared and plus c. We'll just get the answer of that. So we have to be following this long procedure. Now let's look at this. The denominator of that. The denominator of this one, our f of x is 2x squared plus 6x minus 11. So if you differentiate that, you're going to have 4x. You're going to have 4x plus 6x minus 11. You're going to have 4s plus 6s. Okay, differentiate 11. You're going to have no. Differentiate 2. You are 2s. You're going to have 4s. Differentiate 6. You're going to have 6. Differentiate 11. You're going to have 6. That equals 4x minus plus 6. 4x plus 6. That's what you're going to have. Now let's check. If you multiply this 2 times 2, that is 4x. 2 times 3, that is 6. So it's correct. If you differentiate the denominator, the answer will be numerator. Check. This one is 4s. This one times this 4s. Then 6, not this one 6. So the final answer to the question will be equal to log e of the denominator plus c. That's what we're going to have as the final answer to that problem. Now let me assume it happens like this. Let's say 4b, 4a, okay, 4b integral. Let's say this one is 4a integral. Let's say 2 plus that's 2s plus 3 dx over 2x squared plus 6x plus 22. Let's say we have something like this. Our function of s here is 2s squared plus 6s plus 22. Then the f prime of s will be, differentiating this, you're going to have 4x plus 6. And then you're going to have 4s plus 6. But what we have is 2s plus 3. It's not 4s plus 6. But if I multiply it by 2, it's like this answer. Look at it, there's a case like you have some cases like this. In which if you differentiate it, the answer will either be lower than what is here or higher than what is here by a particular multiplicator. So that will multiply it, and the answer will be the same. For example, now this one is lesser to this by a multiple of 2. That is 2 times. For example, now 2 times 2, what is that? 4. 2 times 3, what is that? 6. So a multiple of 2 is the difference between the two. So what you will just do, if this is higher than this by a multiple of 2, you write the answer out and divide the answer by that 2. If this is higher than this by a multiple of 5, you write the answer out and divide the answer by that 5. But I'm not going to do it like that. Look at how I'm going to do it. I'm going to do it this way. So since this is 2 times this, I'll just multiply this one by 2. 2x plus 3 dx all over 2x squared plus 6x plus 22. Look at what I'm going to do. Now, if I differentiate this, the answer will be this now. Well, I've got 2 times 2x, that is 4x. 2 times 3, that is 6. But this question and this one, they are no longer the same thing. Why? Because of these two. These have changed this question from this. Now, I have to cancel out these two again so that the question will still be the same. Now, how can I cancel 2? I will multiply everything by 1 over 2. If I multiply it by 1 over 2, if these two cancel these two, the question will be the same thing. Now, I explain. This question here is not the same thing as this. I have to cancel out these two with something. If I want to cancel out 2, I have to multiply it by 1 over 2. So if I multiply everything by 1 over 2, these two will cancel out these two, the question will be the same thing. But I'm not going to multiply because I differentiate this, that's not this. That means this 1 over 2 will still be present in the answer. That's what I'm trying to say. The 1 over 2 is using, we use this 1 over 2 to correct this so that the question will not change. I don't know if you are following. This 1 over 2 is here to correct this one because this one is not from the question. Now if this one cancel this, the question will still be the same. So if I differentiate this one, the answer will be this. So I will take the log of the denominator, 2x squared plus 6s plus 22 or pass it to t. That will be the final answer to that. That will be the final answer to that. So let's look at this. The denominator there, f of x is 6 plus 5x plus 5s squared. That's what we have there. Then if I differentiate it, I'm going to have 0 plus 5 plus 10x. That's what I'm going to have. 0 plus 5 plus 10x. So this is also another issue. Now let's check. This is higher than this. We have 10x, we have 2x, we have 5x, 5 here, we have 1 here. So this is higher than this by a particular multiplicator. So what will I use to multiply this numerator that will make the numerator equivalent to that answer we are having? If I use, let's say, what multiply 1 to get 5? That is 5. 5 times 1, that is 5. 5 times 2, that is 10. Now, wow, that's nice. So this is higher than this by 5 times 5. Times 5. If I use 5 to multiply everything here, I'm going to have this. So look at what I'm going to do. The same thing here. So what I'm going to do now, I will use 5 to multiply this so that the answer will be equal to that. Then we have 6 plus 5x plus 5s squared dx. Now, this question is different from this. This question is different from this in the sense that this 5 is not from the question. So what am I going to do to correct this 5 now? I will multiply everything. By 1 over 5. Because if I multiply it by 1 over 5, 5 will cancel 5. The question will go back to the normal state. So this 1 over 5 will come out first. And I will say, since if I differentiate this, the answer will be this. I will take log of this denominator, 6 plus 5x plus 5s squared. Then I'll add plus c to it. So I'm having 1 over 5 log e of 6 plus 5s plus 5s squared plus c. That's what I'm going to have as the final answer. So let me just give you guys a check. If you discover that this denominator, after you have differentiated the denominator, it is higher than the numerator by a particular value, write the answer out by taking the log of the denominator plus c and divide the answer by that value. But this one was higher than this by 5. Was divided by 5. Times 1 over 5 means divided by 5.